Assalamualaikum warahmatullahi wabarakatuh. My name is Rina Fianti, and today I'm delighted to present to you a video presentation on my journal resume for the subject of sensor chemistry, assisted by our esteemed lecturer, Ms. Armelia Majid. And the title is Persistent Nitrogen Dioxide Gas Sensor Based on Gallium-3 Hexagonal Pits at the Room Temperature, published on 15 August 2022. So the agenda of the presentation today, the first is introduction, secondly, why using gallium-3, third is research method, fourth is key findings, fifth, how does this sensor work, and lastly is conclusion. First of all, we should look introduction. Because existing air pollutants are increasing daily and affecting the environment, such as acid rain and photochemical smoke, many researchers are trying to overcome and mitigate the effect of these gases, one of which is nitrogen dioxide gas. It is essential to monitor environmental pollution and maintain human safety. Until now, various efforts have been made to improve the response, stability, selectivity, and limit of detection on metal oxide, semiconductor, and two-dimensional material sensor. However, sensor selectivity is still an urgent problem to solve in two-dimensional natural gas sensors, such as quickly collapsing and oxidizing. A new idea emerged by using gallium nitride, which has been widely used as a photodetector and light-emitting gear. But maybe we should asking why using gallium nitride? The reason is the semiconductor compound was chosen over the order to overcome the weaknesses above is that it has thermal stability that looks very good, electromobility, high cooltech, and high breakdown voltage. However, this compound still has drawbacks, namely the surface connection that limit its application in gas sensor. Therefore, the most effective with etching method is used to overcome this. And this required the ultraviolet try to demonstrate a hydrogen dioxide gas sensor in temperature 25 Celsius and relative humidity 34% air based on gallium nitride with nanomicrostructure using wet etching with liquid alcohol, so that it can be made sensor based on high quality and cost effective wet etching method to use to overcome this. So what is research and method used in this paper? So the section itself consists of four parts. If discussed briefly and in general itself, the first discuss how gallium nitride is growing, where the P gallium nitride layer was grown on sapphire substrate using metal organic chemical vapor deposition. The sapphire substrate undergoes a pre-treatment step under hydrogen atmosphere at 1050 1070 Celsius for 10 minutes, followed by cooling down to 550 Celsius to create grow buffer layer with approximate thickness. The temperature was then raised to 150 Celsius to grow the P gallium film, which had thickness of around 4 micrometer. Finally, the gallium was deposited on the sink fast separator at 190 Celsius with a doping concentration of 1018 centimeter. Then the manufacture of the sensor itself is outlined in the following figure. We should look at this. Before sensor fabrication, the P-type gallium sample were cleaned, shortly followed by baking it at 150 Celsius for 15 minutes, then take out the P-type gallium sample with 8 in molten alcohol for different times such 10, 20, 30, 40, 50, 60 minutes at 330 Celsius to fabricate P-type gallium-nitride and High-P respectively. So after wet aging process, the sample were cleaned again in order to remove surface atoms. Multilayer was deposited with zero mass on the surface to fabricate the P-type gallium-nitride High-P gas sensor by the means transporting the equipment, which are the working gas. And then there's material characterization using SAM and EDS to observe the surface morphology and component of the P-type gallium nitride He sample. In contrast, high-resolution X-ray diffraction is used to identify crystalline paths. Lastly, the gas sensing performance is carried by CGS-MT Intelligent Gas Sensing Analysis System. For that, during the test process, nitrogen dioxide is injected into the airlock chamber with the microstring a certain amount of ammonia, trimethylamine, ethanol, and methyl alcohol with water is injected into the evaporator of the test chamber with a microstring. Then an ultraviolet environment also created by the UV LED plus and the sensitive gas chamber is lit during the measurement process. So what is Chi findings? So initially it was discussed in this paper result and discussion section. The selectivity of the gallium heat sensor was tested by exposing it to different gases. Moreover, is it known that the sensor responds to 1000 ppm nitrogen dioxide gas is much higher than that of ammonia, TMA, acetone, carbon dioxide, ethanol, and N-butyl alcohol, which respond for ranging from 6 to 50 to 4. When the sensor was first tested in mixture of 20 ppm nitrogen and 20 ppm sulfuric gas, especially ammonia, the result was the sensor responded to the gas mixture defined within plus minus 2% of the expected response for 20 ppm ammonia, indicating high selectivity. Um, gallium nitride heavy sensor resistant and response were measured in dark and UV environment. The sensor instead showed a high response to 1000 ppm nitrogen dioxide under UV illumination compared to dark environment, showing a response increase of 1 to 3 time in the presence of UV light. Gallium nitride heavy sensor recovery time is reduced under UV illumination compared to a dark environment, indicating faster recovery with the help of photogenerated energy. But we should know how do this sensor work. So the p-type gallium nitride exhibits p-type behavior when exposed to nitrogen dioxide and oxygen. When the gallium nitride Hb sensor is exposed to nitrogen dioxide gas, the nitrogen dioxide molecules are adsorbed into the surface. Moreover, nitrogen dioxide molecules react with the electron on the surface forming nitrogen dioxide species under UV illumination. Photonic energy helps to dispersion absorb oxygen ions by combining them with photogenetic holes. Ultimately, Ultimately, the desorption of photogenesis whole contributes to the desorption of oxygen ions. The gallium nitride hybrid mechanism under UV illumination involves the practical separation of photogenetic holes and electrons in the surface depletion region. The holes move towards the gallium nitride Hb surface, making the oxygen ions easy to dissolve. Oxygen desorption rules surface side, allowing continuous absorption of nitrogen dioxide so that desorption rate increases with the whole of photon energy. So the conclusion in summary, with etching process successfully fabricate nitrogen dioxide gas sensor based on P-type gallium nitride Hp, the results clearly show that KO hot treat gallium nitride Hp had a higher response than pure gallium nitride under room temperature condition. Gallium nitride Hp responds much more to nitrogen dioxide than the other gases. The response of gallium nitride Hp to 1000 ppm nitrogen dioxide is also known to be more higher than the dark environment, indicating an effective increase in the response galvanometric behavior through photoenergy. The immediate and efficient gas surface treatment also present a promising approach to improve the gas sensing performance of galvanometric-based material. So this video presentation has provide an overview of my journalism. I would like to express my gratitude to Ms. Amelia Majid again. I hope that this presentation has been informative and insightful, shedding light on the exciting field of sensor chemistry. Thank you all for your attention. Wassalamualaikum warahmatullahi wabarakatuh.